All right, welcome back for example 3. Example 3 is going to be dealing with paragraph proofs. So far we have looked at flowchart proofs, right, that just have a bunch of circles and arrows and you write all the justifications below. We've talked about two-column proofs, but the third type of proof is going to be a paragraph proof. And a paragraph proof presents the steps of a proof and they're matching reasons as sentences in a paragraph. So it's just basically everything written down. And you can really go maneuver through the paragraph proof, two-column proof, and flowchart proof pretty easily. They all have the same information. It's just 3 different formats for writing the information. And so you're going to have to be familiar with all 3 throughout this course and the year. So we're going to talk about a paragraph proof in example 3. But before we do that, we have to talk about these 2 theorems. Now, this one right here is super, like you are going to use this one all the time. This is the vertical angles theorem. And we talked about vertical angles, I think, at the end of chapter 1. And basically, it's just pretty simple. Vertical angles are congruent. So if you have 2 lines, it's the angles that are directly across from each other, and they're just the same. So if this was 150 degrees, then this angle would be 150 degrees, okay? Angle A and angle B, they're congruent by the vertical angles theorem. Okay, the next one states if 2 congruent angles are supplementary. Okay, so let's think about that. Supplementary are 2 angles that add up to 180 degrees, which means they're a straight line. And so if we have a straight line and we need 2 angles which are congruent to each other, there's really only one option, right? The only option for those 2 angles being congruent is that one is 90 and the other one is 90. Right? There's really no other option for 2 angles that are congruent and supplementary. So yeah, they equal 180 degrees, they're congruent, therefore they're both 90 degrees. So it says if 2 congruent angles are supplementary, then each angle is a right angle. And then this would be the reasoning for it. And they use that conditional statement stuff right here. It's basically if congruent, we should probably say 2 congruent angles are supplementary, then they are right angles. And that's the reason for it. So if angle 1 and angle 2 are congruent, and angle 1 and angle 2 are supplementary, then angle 1 and angle 2 are right angles. Okay? And go ahead and make that little, if 2, make this a 2. If 2 congruent angles are supplementary, then they are right angles. Okay, so these just need to be on flashcards. You need to memorize them. Okay. You are going to use vertical angles all the time. This one, here and there. This one, all the time. Okay, vertical angles theorem. 2 angles across from each other are the same. All right. So let's go ahead and look at our example for example 3. So we're given this, we have to prove this, and here's the paragraph proof, but we're not going to look at that quite yet. We're just going to kind of look at this information, and it's off of this picture here. So it basically says measure of angle 1 plus the measure of angle 2 equals measure of angle 4. So angle 1 plus angle 2 is equal to angle 4. So first, let's just, before we get there, let's look at what we have. Okay, we have a triangle. We have a line. It looks like there's 2 angles here, so this could be a, linear pair theorem, which could then go to, both of these are supplementary, and they both add up to 180, and we have a triangle. So just looking at the picture, it's just kind of good to just kind of look at it and see what we have. All right, so that's kind of what we have here. Now, let's go ahead and look at what they're giving us. So they're saying the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. So this angle plus this angle equals this angle. All right, that's all that they're giving us. We need to prove that the measure of angle 3, the measure plus the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Okay, so we need to prove that. Perfect. So what I'm saying is they're giving us this information. From here, I don't really see a whole lot of anything else that we can do, right? That's pretty much, that's it. That's given. Then what I would do is I would really go to this information, right? Whenever you see that straight line and those two angles, you know that that is a linear pair. So what we can say is we would state that angle 3 and angle 4 are supplementary. Does anybody remember why we can say that? That would be the linear pair theorem. Pair theorem. I think I'm writing. Okay, and then from here, we could say that the measure of angle 3 plus the measure of angle 4 equals 180 degrees, right? By the definition of supplementary angles. Right? Okay, yes. So that's basically it. And so remember how I said a couple sections ago, I said these two go hand in hand. Linear pair theorem and definition of supplementary angles. Just as a strategy, as a tactic, as a tool in your belt, know that whenever you see a straight line, it's into two angles. You can say that they're both supplementary because of the linear pair theorem, and then you can make it into an equation because of the definition of supplementary angles. All right, so from here, we can't really do anything else. That's pretty much it. But what we can do is, if you see this, is if we go back to that first piece of information, you should see, right, because we're trying to prove this, you should see that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. So if you look here, sometimes, okay, so what do we have? What do we have? So this is what I'm trying to prove, right? So I have this measure of angle 3. I have this measure of angle 3. I don't really have that, but I have the 180 here, and I have the 180. But what do I know? I know what the measure of angle 4 is equal to. The measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So instead of writing the measure of angle 4, that is the same thing as this, and I can just substitute that in here, and then what would I have? I would have the measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 is equal to 180. So this is what I would have from here, right? This is what I would have from here. But then this pink would be substituted in for the measure of angle 4, and then there I have it. I have my proof. The measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. All right? So that's really how we solve this proof. Now let's go ahead and look at how it's stated, and you could do that through, that would be substitution, right? So substitution. All right? So let's look and see how they wrote it in the paragraph proof. So it's really important to look at the key words. So because you're going to have to write a paragraph proof. So it says, it is given that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 4. So that's right here, right? That's the statement. It's given. Angle 3 and angle 4 supplementary by the linear pair theorem. That's what we have here. So measure of angle 3 plus measure of angle 4 equals 180 by definition. And it's really by the definition of supplementary angles, but they just say by definition. By substitution, the measure of angle 3 plus the measure of angle 1 plus the measure of angle 2 equals 180. So that's pretty much it for the paragraph proof. So then all we need to do, but what it's good to look at the keywords. So like it is given, that's one way to make a sentence, right? Talking about that stuff's given. So it is given that measure of angle 1 plus measure of angle 2 equals measure of angle 4. Angle 3 and angle 4 are supplementary by the linear pair theorem. Okay, that's pretty easy. So this, by definition of supplementary angles, I probably would have had that. And then just starting off by substitution, you know, then that. So there's a couple key words there, but, you know, not a whole lot. It's pretty just straightforward. So then we just take this information and then just write it in our 2-column proof, right? So we're starting here with the given information. That's given. Then from there, we talk about angle 3 and angle 4 are supplementary. I don't know if by the linear pair theorem. You're going to use this one a ton. I mean, it's almost like linear pair theorem and vertical angles theorem. They're like two theorems that are in a competition for how often they can get used. And you'll see that as the chapters move on. Then from there, we go ahead and just change this information into equation. Measure of angle 3 plus measure of angle 4 equals 180 by the definition of supplementary angles. And like I said, please, please, please look at this. This to this. I swear this is a technique you're going to use a ton, knowing that those two are together. You see the straight line up here. You look at that. There's two angles forming a straight line. Okay, there. You can see that they're supplementary, then you can write your equation. So that's a tool that you definitely want to use in your tool belt every time you see something like that. Just know that it's an option. Most of the time you'll use it. Some of the times you won't, but just know that this is the format, okay? You see that picture, boom, they're supplementary, then you can write your equation. And then we basically just substitute, right? So measure of angle 3, and then instead of writing measure of angle 4, we write this bit here, plus measure of angle 1 plus measure of angle 2 equals 180, and that's just substitution. And that's the proof. Okay? Let's go ahead and look. Oh, before I wanted to tell you something. It's actually kind of funny. I don't know if it's funny, but if you look at this right here, this measure of angle 1 plus measure of angle 2 equals measure of angle 3. This is actually a theorem that you're going to learn. It's called the exterior angles theorem. And basically 4 is an exterior angle of this triangle. And so these two, you see how 3 and 4, they're a linear pair. So it's the other two. If you take these angles and you add them together, you get angle 4. So this is one that you're going to have to memorize. And also this one, the measure of angle 3 plus the measure of angle 1 plus the measure of angle 2, this is actually a theorem as well. And this one is called the Triangle Sum Theorem, which just basically means that all of the angles inside of a triangle, they all add up to 180 degrees. So I just think it's funny when I look at them because it's like you're starting with one theorem and then they're having you prove another theorem. So you'll learn about these soon enough, but I just thought I would point that out. Okay, let's look at the next example. All right, where's my paper? Okay, so I'm gonna kind of cover up that paragraph proof. It's a doozy. Okay, let's look at it. Let's try to think our way through it first. So, this says that, so this is the picture. There's a lot going on, right? You kind of have this angle here. There's a line cutting through it. I mean, there's just a lot. So what does it say? It says that angle WXY, so WXY is our, WXY is our, what does that even mean? Is A. This is probably supposed to be A, is our, that makes no sense. I probably did these notes when it was really super late. Is a right angle. Okay, WXY is a right angle. All right. And then it states that angle 1 and angle 3, you can see those arc marks, are congruent to each other. Okay, so those are the same angle. What we have to prove is that angle 1 and angle 2 are complementary. And we know that complementary means that two angles add up to 90 degrees, right? So what do we know here just by looking at this? So like, why would they tell us that WXY is a right angle? WXY is a right angle. Well, they probably tell us that because we know that if it's a right angle, then that means it's 90 degrees by the definition of a right angle. So this whole angle is 90 degrees. And if you look at it, you can see that this angle is actually like a angle addition postulate, where there's two angles that make up the 90 degrees. So really, angle 2 plus angle 3 is equal to 90 degrees, right? So we know that angle 2 and angle 3 are complementary. We know that. And what do we know? We know angle 1 and angle 3 are the same. So instead of writing angle 3, I could substitute 3 in for 1 because they're congruent, and then I would have angle 2 and angle 1 equaling 90 degrees, which would mean that they are complementary there, okay? So really that's the place, that's the direction that this proof is headed. So let's go ahead and read the paragraph proof and see how they laid it all out. Okay, so it says that since angle WXY is a right angle, then what we know is the measure of angle WXY equals 90 degrees by definition of a right angle. Okay, then it says by the angle addition postulate, we know that the measure of angle WXY is equal to the measure of angle 2 plus the measure of angle 3. Then by substitution, they write down that the measure of angle 2 plus the measure of angle 3 equals 90 degrees. So they substitute this in because we know that WXY is a right angle and it equals 90. So instead of writing WXY, they substitute 90 in for WXY, and now we have measure of angle 2 plus measure of angle 3 equals 90 degrees. Okay? So remember, we're trying to get angle 1 and angle 2 are complementary. So right now this is basically